right, let's get started. Okay, so hope you had a good fall break. And this week will be an easy week because there's no assignment due, just the midterm, and that just takes 80 minutes. So that should be good. PS7 is out. It's due the end of next week. I'm trying a couple different things with it. So you're implementing 3 different classes and then 3 other classes that are test cases for the first 3 classes. And so there's actually PS7A through 7E. You hand in each class separately, so be sure you hand in all that stuff. For the non-test case classes, I've given you, you'll be able to see the results of all the test cases. So there won't be any mystery about about hidden test cases. However, I've removed all clues about why you failed test cases. So they're just called test case 1 through test case 20 or whatever. And you either pass it or not. So see how that works. For the test cases you're handing in, the way it'll work is if you hand in, if you have a bad test case, one that fails and run against correct implementation, the gray scope will simply ignore it and use the remaining test cases to run against my incorrect implementations. You don't have to get all those, say there's 12 incorrect implementations, you only have to do 11 of them, detect 11 of them to get full credit. So there's a little bit of slack there. You don't have to get the last one, which sometimes is a problem. So that's the assignment. Midterm is the order of business this week. And just to remind you, it's Wednesday. It is either from 3 o'clock to 4:20 or from 5 o'clock to 6:20. And at 3 o'clock, I want those with last names beginning with A through P to come here. And then Q through Z will go next door in Web L103. The 5 o'clock, the hybrid section, midterm, will be in here at 5 o'clock. I've heard from a few people with issues of various kinds where they need to make special arrangements for the midterm. I need to hear from everyone, so hopefully I've heard from everyone. So I don't need to hear from everyone. I need to hear from anyone with a problem. So that, be sure that you bring your ID card to the exam, because when you hand in the exam, we'll ask to see your ID card. You can bring one 8.5 by 11 inch sheet of notes. So one sheet of paper. You can write front and back. You can handwrite on it or print it out on a laser printer, whatever you want to do. Everything else needs to go, basically be inaccessible during the exam, so backpacks on the floor and such. I don't have a slide for this, but basically the midterm covers the first 6 weeks of the class. First 6 weeks of lectures, labs, midterm, not midterm, problem sets, caddis, and so on. So that's the mechanics of the midterm. So are there any questions about that aspect? Like the ground rules for taking the midterm, or about the problem set? Yeah?
So the midterm will fairly resemble the practice midterms.
Right, so there are 2 practice midterms. We're going to go over the one from 2017 today, the one from 2018 in the lab tomorrow. And what I do to create this year's midterm is I'll take the 2018 midterm and change it. So it'll have sort of the same look, just have different questions. Yeah?
Can you type the sheet of notes?
You can, yep. You can type the notes, whatever. But you'll have to turn in the sheet of notes. So if you value it, make a copy before you come. Yeah?
Are there any rules about what we can and cannot write in the sheet of notes?
There are no rules about it. There's never been an issue. Yeah? Yeah?
Is PS7 due this Thursday or?
No, PS7 is due next week. But it's been out a week actually, and very few people have done it, but a few have. Yeah?
It said on the PowerPoint, like 5 o'clock we should all be practicing.
That's not, okay, so for the regular lecture section, which is basically you folks, you come at 3 o'clock. 5 o'clock's for the hybrid section, the ones that watch the videos. Yeah. So you come at 3, leave at 4:20 like usual. Okay, any other questions? Yes?
Will you be posting the answers to the old midterms?
Right, so I'll post the solutions to the 2017 one after class today and the 2018 one after labs tomorrow. Okay. Okay, so one thing that's different about the midterm is that you'll be programming on paper. So if you looked at the samples, you know, you don't have to write large amounts of code, but you do have to write bits of code. Implement simple methods, or tell me what code needs to be put into a loop to make it work right. And that'll be a new experience. And so it's actually a thing that's worth practicing. You know, you won't have Eclipse telling you, giving you hints about what the methods are called, or telling you when the syntax is wrong. And we deal with that in 2 ways. One is we let you bring the sheet of notes. So things that you're depending on Eclipse to remind you of are good things to put on the sheet of notes. The other is when we grade it, we're not as strict as the compiler. So, you know, if you leave out a semicolon, we're just going to overlook that. So we're flexible. But still, it's good to practice. So practice right now. Pull out a piece of paper and do what it says there. Write a stub for a static method called isPrime. It takes an int as a parameter and returns true or false. See if you can do that. There'll almost certainly be a question on the midterm like that. Okay, who could tell me what they have? What does a stub for that method look like? Yep.
Public static boolean is prime integer.
Okay, hold on. So public static. Boolean is the return type because I said it returns true or false.
Yeah, is prime.
It's called isPrime. Something like that. It takes one parameter, which is an int. But you got to decide what to call it there. And how do we? What do we have to do besides that? Okay, return what? Yeah, it doesn't really matter what you return. Return false is fine. Is that all? What? Yeah, we need some Java doc. And I'm not going to take time to write it, but basically it would say, reports whether n is prime. Okay? So that's not so hard, right? If you remember how many, there's 2 stars in a Java doc. That's, again, something we wouldn't be very strict about. Any questions about that? Yeah?
When we write the code in midterm, you want us to include the Java doc?
Well, if I ask you to, if I give you a blank page and ask you to write a stub, Java doc's part of a stub. More typically, what you see in the exam, though, is if let's suppose I ask you to implement isPrime, which I wouldn't. That's not the kind of thing I would ask, but what you would see is something more like this. I would give you all that stuff, and you'd write the implementation in the box. Or I would give you part of the implementation and have several boxes to fill in. Okay, now what about this? Let's go. No. Yeah, this is not working. Let me try again. Didn't want to go back. All right, this is what I'm trying to get. So now, assume that isPrime method exists, the one you just stubbed out. There's what I was talking about, sort of a blank space to write some code. So I want to write a method that returns a list containing all the prime numbers less than n. So you have isPrime to work with. So I want you to accumulate a list of integers that's all the prime numbers less than n. So try that out on paper. That's a little more substantial. All right, well, let's talk about it. This actually sounded like a midterm. It was kind of quiet, except a few people have coughs and sniffles, and there's sort of a feeling of nervous tension in the air. So that's what it's like. So what's the body of this method going to look like? First of all, I've asked you to do this. It's going to take a loop, obviously, because you got to look at a bunch of integers. What type of loop are we talking about? What? Well, besides, okay, yeah. We can use a for loop or a while loop. That's not what I was after. Accumulation loop. So that means we're going to have an accumulation variable, then a loop to accumulate the stuff into the variable, and then we return the variable. So what is the accumulation variable? What type of thing is it? Right, so it's that array list of integers. And I'll call that primes. Okay, so we got that, and we know that when we're done, what are we going to return? Yeah, we're going to return those primes. And in between, we need to fill out the array. So we need to look at all the integers less than n. Well, put on all the integers. We don't have to look at the negative ones. We don't have to look at 0 or 1, because we know 1 isn't prime. So basically, from 2 on up, we got to examine and see if they're prime. So how would we do that with a for loop if we wanted to? Well, for loop would look through the integers from 2 up to, but not including n. What's that? Okay, well, we have to declare a variable, so we'll say for int, I'll call it p equals 2. Okay, while what? P less than n. All right, so we look at each one in turn, and what do we do with that number? What do we do with p each time through? Okay, so if is prime of p, what do we do if p is prime? Right, we add it to the list. Primes.add p. All right, so there it is. Any questions about that? Yeah. If you start at p at 0, no, it wouldn't get marked down. Yes?
Would you mark down points if you used a while loop instead?
No, while loop's fine. Yeah, while loop, for loop, I mean, whatever. Yeah.
So if the user inputted 1, it would just skip over the 1?
Say again?
If the user inputted 1 for n, it just skips over the 1.
Yeah, so if the user asks for all the prime numbers less than 1, n is 1, then we get back an empty list.
Okay.
Right. Yeah.
Will we need to use like try and catch loops for this midterm?
Well, there might, for this question it's not needed, but there probably will be a question where you need to use tries and catches. Yes? Oh, the method didn't declare a variable, didn't declare an array list. The return type was array list of integer. But the parameter was in. Yeah.
So if you forget array list at the beginning and you go back, can you just do like an arrow, or what's the best way to add it in this paper?
Oh, if you forget?
Yeah, if you forget, I think that would be.
Yeah, so if you need to edit your code, you just got to write it off to the side and draw an arrow.
Okay.
But here's the problem. So we grade the exams using GradeScope. And typically, every question, every answer is going to go into some sort of box, or if it's multiple choice, there'll be bullets to shade in. Don't do this. Don't write your correction off to the side and then draw an arrow like this, because GradeScope is just going to show us what's in the box. Now, if we see an arrow coming in from the outside, then we're smart enough to zoom out and see what was written. But we may not notice what you wrote off to the side unless you need to make some sort of mark inside the box to tell us to look outside the box. Now, if you forget, you can, we do regrades on the midterm. If you think we graded a problem wrong or we overlook something, we'll regrade it. But it's best not to have to go through that. Yeah.
Do we have to write in pen or pencil?
You can write. You don't have. You can use pen or pencil. Doesn't matter. Yeah.
So from that previous question, if say we ran out of space for some reason, we could make some indication that
Yeah.
there's more over here.
Yeah. So I try to give you plenty of space, but some people write bigger than others. If you have an answer that seems like it's far bigger than the box I gave you to write the answer in, what does that mean? It's probably not the right. It's probably the wrong answer, or not the one I'm looking for. Yeah.
Okay, so let's suppose that when you do that method, like you said, you put the A as capitalized. So how much point that will be like the quarter stone thing?
Okay. So yeah, you get partial credit. So let's say you left off the semicolon here. Say you forgot that semicolon. We wouldn't take off any points for that. Suppose you couldn't remember what the method was called there, and you guessed and you wrote, instead of add, you wrote insert. I doubt we'd take any points off of that either. Because, we look at this, and if all you did was use the wrong method, that you could easily find out if you were allowed to look in a reference. We're not going to sweat the small stuff. What's really hard, if I don't know, like if you instead of P++ you said P minus minus, yeah, that wouldn't work. We take off something for that, but you'd still get partial credit. We like to give partial credit. Okay, any other questions? So that's a good exercise to try to, get used to writing some code on paper, because it is a skill that we use a lot of. Do you have a question?
So I was just curious, does simply returning primes give us everything inside that array?
Yeah, returning primes returns the array list that primes references. Yeah. The thing to realize, array lists are mutable data type. So when we say primes.add, we're not creating a new object, we're just adding to the existing one. And so when we refer to it down here at the bottom, there's only been one array list and we're returning it. Any other questions? Yeah?
Why is it minus instead of plus?
Oh, why? No, I'm saying if you wrote P minus minus, we would deduct points, but you'd still get partial credit. And even, let's say you did everything else right, except you wrote less than or equal to n. We'd probably have a debate. Usually the TAs want to be stricter and I want to be more lenient. And usually I win those arguments. So I'm not encouraging you to be sloppy. I'm just trying to show you that it's not all or nothing. And if you can, look at it from my point of view. Okay, you clearly understood. If you wrote that, you clearly understood what you're doing. You just made sort of a minor error. Is that even worth taking a point off? Yeah.
So, like, the way that you referenced is prime, even though we only wrote that as a method stuff, would you write in, like, use is prime in this method?
No, in my directions I said, so she's asking, do you have to say anything about is prime since you just stubbed it out? In the actual question here, it said assuming is prime exists. So you don't have to go implement it or anything like that. Yeah? More time than I gave you just now. But it just depends. Let's say it's worth 10 points. So that's 8 minutes. If you think of 80-minute test, 10% of it would be 8 points. That'd be 8 minutes. Yeah, if you didn't get finished, I know you weren't finished when I interrupted you, but you never are. So, yeah.
So I know capitalization is important, but how lenient will you be on capitalization?
Oh man, now capitalization. You know, the only time we might be lenient on that is, I always begin the exam with, here's some things, what type are they? And there, double and capital double, lowercase double and uppercase double are two different things. So be careful there. But some people, they print their entire exam in uppercase. And so, yeah, we have a hard time taking all points for capitalization. So just be aware it does sometimes matter. So if you don't want to rely on our leniency, pay attention when you're writing type names. Okay, so the rest of this slide deck here, I will come back to if we have time at the end. It just takes off now and it goes through a laundry list of midtime, stuff we've talked about, high-level concepts, programs, specifications. So you can think of it as a study guide. It makes for a pretty boring lecture to read these things to you, so I'm not going to do that. But I will go look at some highlights later on. But the main thing I want to do is go over the sample midterms, so we'll do that next. Now, this test is from 2017. So in 2017, I wasn't using GradeScope to grade the midterms. And what I learned when I started using GradeScope was I can't put boxes right next to each other because people they say write a type here and they'll do like, they won't respect their descenders will go into the box below. And so now I put little gaps between the boxes to make that better. But try to write inside the box.
Tail of the Y goes out of the box. Is that a problem?
No, it's not. It's not a big problem. And the grades are fair in the end. It just helps us grade faster. Because, okay, let's do this first one. Here are some expressions. What's the type of each expression? Guarantee you this will be the first question. Different expressions, but in different answers. Same type of question. So, what's the type of that expression? Right, it's a string builder object, and so you would write string builder in here. Now, just to tell you what GradeScope does, it goes through all the exams. So we scan the exams in. GradeScope goes, and I upload a blank exam, and I draw a box where I expect the answer to be. So it'll just be that box I provided. And GradeScope goes and finds that box on everyone's exam and produces an image of it. And then it will go and it actually does some character recognition, and it will try to sort every question where it said string builder into one set, and every place where it didn't say string builder into another set. And then we can just say, we'll just quickly look at all the things that GradeScope says say string builder and give it credit. So we can grade like 300 answers at once like that way. You don't have to look at them individually. And then we have to look a little more carefully at the ones that it didn't recognize as saying string builder. So the neater you can write, the more you can stay in the box, the less time it takes us to grade. And we're in a better mood and we give them partial credit. So try to write in the box. Okay, what about this next expression? All right, that's an int. The answer is an int. And I know I was looking at this before class, just practicing, making sure I could write on the exam. And I kept doing things. I think I wrote 1 there. I forgot what I was doing. I evaluated the expression instead of writing the type. So don't make that mistake. I want to know the type here. There's a value one is the next question. Okay? This next one I missed. I always miss questions on my exams. I was going too fast and I missed it. So what type of thing do you get back when you take a substring of a string? Yeah, I heard char and I heard string. Which is it? It's string. I wrote char because I'm thinking, okay, the answer is, well, what would be the value of that expression? The string containing E. And I was thinking, it's a character, but it's not. It's a one character string. So string. Okay? What about this? new scanner, this is a test, so we create a scanner object and immediately invoke hasNextInt on it. It's a Boolean. Popular wrong answer would be scanner. Yes, a scanner is created, but the expression itself is it would be true or false. What do we get when we multiply the int2 by the double 0.5? A double. And what's that one? That's a char. Okay, so that's 6 quick points. And you look at the 2017 exam, the 2018 exam, the 2016 exam. They all start with, I didn't show you the 2016 exam, but I'm just telling you they all start with that same type of question. All right, what about here? Here we're asked to evaluate the expression. So we don't want to know the type, we want to know the value. And look right here, it says each answer must be a valid Java literal. And it also says punctuation counts. So here the answers are so simple, you know, I'm not asking you to write code, I'm just asking you to evaluate it, that we can be a little bit picky. So and I ask you, what happens when you parse the string containing 1.5? Right, the value of that expression is the int 1.5. So what I want you to write is, what would you write into a program if you wanted to denote 15? You'd write that integer literal, that int literal right there, 15. Okay? We want to know the length of that string right there. 5. So we want the integer literal 5. Okay? What's 1 divided by 2 times 2?
0.
All right. Why is it 0? Well, I wouldn't call this round off error. 1 divided by 2 is just 0. Because integer division, you throw away any remainder. Round off error is more of a floating point concept. It's just the way integer division works. So 1 divided by 2 is 0. Multiply it by 2, you still get 0. So far, I've just written integer literals. That's easy. Okay, what's that next one? We create a scanner and pull out the first token, basically. We call next on it. Okay, AB. Now, remember I said punctuation counts. So what I want is, how would you write the string AB into a program? I would say double quote, AB, double quote. Okay, that is correct. You don't want to just write AB. That is not a string literal. Okay, what about that? Not 2 greater than 3. Right, 2 is not greater than 3. 2 greater than 3 is false. Then we negate it. We get true. And the literal is true. What's that? That's weird looking, isn't it? What are we actually doing? We're creating a new array of length 5. We're creating another new array of length 5. So now we've got 2 arrays of length 5, and we're asking double equals. So I don't know that I've stressed this much this semester. I'll certainly do it next week. When you do double equals on 2 objects, what question are you asking? Apparently someone stressed it. Right. Maybe you're asking, are they the same object? Are they physically the same object? And no, those are 2 separate arrays. That's why I always tell you, don't compare strings with double equals, because when you want to know if 2 strings are equal, you want to know, do they contain the same characters? You don't want to know if they're physically stored in the same place in memory. So sometimes it's useful to be able to compare with double equals. Sometimes you need to know if 2 things are physically the same object. But more often you don't, that's not what you mean to do. That's why I encourage you not to do that unless you know what you're doing. But in any case, the answer is false. But what do we write over here to the right? False. Okay, and the answer, if the answer was a character, we'd write it like that. So that's what I mean by punctuation counts. Okay, any questions about that? Yeah.
For the Boolean, does it really matter how you write true or false, like whether it's all caps or anything?
Well,
Or are you just looking for true and false?
I want a valid Java literal,
Okay.
and true is written in lowercase. But again, we would have one of these, this always happens when we're grading. Joe, should I count this or take points off? And we talk about it. Now, Grayscope makes it easy to take off quarter points and stuff like that. So that's given us a whole new scope for partial credit. But okay, any other questions? Okay. So I just want a sort of a short definition of each of these things. So what word describes the process of taking a simpler view of something by selectively ignoring details? Abstraction. And I can't stress enough how important the concept of abstraction has been this semester. Because, if you insisted on understanding every detail about Java before you wrote your first Java program, if you insist on understanding how the compiler worked and how the virtual machine works and how the computer running it works, we'd never get off the ground. So we're constantly not worrying about the details of how an array list works. We just know these methods do what they say they'll do. That's abstraction. What does a break statement in a for loop do? Okay, it exits the loop. Would the answer be any different if it were a while loop? No. When you hover the mouse over a method, Eclipse displays documentation. Where does it come from? Right, so it comes from the methods Java doc. Okay? Which one of these is a wrapper class? Yeah, integer is a wrapper class for int. What is the size of the? Oh, this one, a little tricky. I try to stay away from tricky questions, but sometimes they seduce me. So, what is the size of the largest possible tree map that maps Booleans to strings? Yeah, the answer is 2. So what is the reason? Right, keys have to be unique. Okay, so the answer is keys have to be unique, and there are only 2 possible keys, true and false. So true can map to something, and false can map to something. There's no other key you can insert to make it bigger. Now, I saw people saying 3. I have an idea why 3, but what was your thinking about 3? Yeah? What's that? Oh, you could use null as a key? Yeah, because that's an interesting question. I don't believe null will work as a key. I was thinking you might, there are 3, you could have an empty tree map, a tree map with 1 key, and a tree map with 2 keys, and you get 3 that way. But the size of the largest one is 2. Okay, what value can be stored in any variable whose type is a reference type? No. So what is a reference type? What's a reference variable? If we say this variable is of a reference type, what do we say? Yeah?
It's not directly holding a value, it's holding an address.
Right, it's holding a reference to the actual thing in memory. But what types of things are reference types? Or I'll turn it around. Everything is a reference type except for some exceptions. What are the exceptions? The primitives. So ints, doubles, chars, booleans, longs, shorts, bytes. Those are floats. So those are the 8 primitive types. I think I said 8 things. And everything else is a reference type. So you can't store null into an int variable, but you can store null into an array list variable. Okay, any other questions about this? Make this a little bit smaller so you can see what's going on. I'm going to do this. That's Okay, take a gander at that if you haven't already. So that's a lot of code to read, but you don't have to write any code. You just got to read it and figure out what it does. So the question at the bottom is, what does G print when it is called? So I'll let you look at that for a few seconds here, and we'll talk about it. Okay, so what do you think? What are the only two possibilities of what G can print out? All right, there are two print lines. It's either going to print what F returns, or it's going to print out the string exception if F throws an exception. If F throws an index out of bounds exception. So we got to look at what F does. So we're passing the string hello and the character X to F. Now this loop right here, what's it doing?
Finding the index of 0.
Right, so it starts to index at 0, and it says while index is less than or equal to s.length. So essentially, it's looking to see if that character, whereas C was the parameter, if the character C occurs somewhere in the string, and if it does, it returns its index. Okay? What if it doesn't contain the string? So we can see right now that X does not occur in hello. So suppose this loop ends without having, so it's a searching loop. Suppose the loop ends without index having been returned. What's it going to return? -1. So you might be tempted to say, okay, it's looking for X in hello, it doesn't find it, so it returns -1, and that's what's printed by G. But what's wrong with that analysis? Yeah.
So when you're since you're searching for the index less than or equal to f of length, while it's searching for the word hello, it'll look for the final index after hello, and then that'll trigger index out of bounds.
All right. So the problem is we're letting the index get too big. So we start the index out at 0, and let's say our string is of length 5. So it's going to look at it's going to look to see if the character X is at index 0, 1, 2, 3, 4, and then 5. 5 is not a valid index. So what's F going to do? It's going to, that attempt, this char at, is going to throw an index out of bounds exception. What's F going to do, though? It's going to catch that exception and return the offending index, which was 5. So what's G going to print out? 5. So this is sort of getting at, do you understand that if, even though an exception is thrown, since it's caught right here, and we return, that this method up here does not see an exception thrown. It's just going to print out 5. So popular wrong answers might be, people might say, oh, it's going to throw exception. It's going to print exception. Or it's going to print -1. But the right answer is 5. That's pretty sloppy. Okay, so that's fairly complex. Any questions I could answer about that? Yeah?
So assuming if you left the while loop broken still, is there a way to actually get it to catch it properly without just returning the 5 and going up to the...
Well, okay, what if you wanted, instead of returning index, what if you wanted to catch the exception, right? What would it take to arrange so that G would see the exception? What do you have to change about the method? Yeah.
Get rid of the catch index out of bounds exception.
Right, we just basically don't do this in a try. We just get rid of the try and the catch. So now when it runs off the end of the string, that index out of bounds exception is thrown by char at. It's not caught by F, so it'll propagate to G. G will catch it and print out exception. Yeah?
Should we put a throws index out of bound exception up there?
Yeah, you could if you want, but typically you only put a throws up here when Eclipse forces you to. And that's when it's a checked exception. So it'll be something like IO exception or file not found exception in a throws. For run-of-the-mill exceptions, the convention is we don't actually put that in the header. Yeah?
Are we allowed to write on the exam? Like,
Yeah. Yeah, you can write on the exam, and just don't write in. Just write your answer in the box. Yeah. It is kind of annoying when there's space off to the side where people could have done their scratch work, but instead they write their scratch work in the box. That doesn't work very well. We figure it out, but don't do that. Yeah?
So if that first catch block in the method G doesn't catch the exception, what is it for?
Okay, so now you're saying what happens if we take this catch away?
Yeah, like, is it there just kind of like to trip us up because the test, or is it actually for us to?
Well, if you take the try block away, then G, when that exception makes it to G, since G doesn't catch it, G will terminate by throwing the exception. And then whoever called it will get a chance to handle the exception. And if no one does, and it propagates back past main, then the program crashes. Okay, so what was the answer? 5? Okay, let's take a break for a few minutes and we'll continue with the exam after that. Okay, so this question, I just want you to tell me what kind of loop you would need to write: accumulation, searching, or optimization. So if we want to return the smallest number from a non-empty array of ints, okay, what's the giveaway? What word in there is the giveaway? Smallest. So you're looking for extreme value, the smallest, the biggest, the brightest, the dimmest. So what's the answer? Optimization. All right, returns a prime number from a list that contains at least one prime. That's a searching one because we've got a list and we've got to find, a prime number. It's not saying even which one if there's multiple ones. So we're not looking for the best prime number, the smallest or the largest, just a prime number. And so that's a search. Okay, we're supposed to return 1 to the n plus 2 to the n up to n to the n. The sum of those, where n is a positive int. That's an accumulation because you're basically looping from 1 to n, computing a term and adding it in each time around. So you're combining the numbers from 1 to n in some fashion. And that's an accumulation loop. You need to write. And returns the longest line from a scanner containing at least one line. Right, there's longest, there's smallest, so that's another optimization. Okay? Any questions about that? Yeah? Okay. All right, let's say he's proposing, suppose we change that second one to say returns all the prime numbers from a list that contains at least one prime. That's more like an accumulation loop. But it has elements of a, no, it's an accumulation loop, but it has an if, so it looks sort of like a searching loop. But I try to, if I do something like this, I try to make it obvious. I don't give any gray area type questions there. Any other questions? So I had a professor when I was an undergraduate that he invented this character called Ben Bitdiddle. And in case you're wondering why you see it on my exams, it's sort of tribute to that professor. So anyway, Ben Bitdiddle usually screws something up. What did Ben Bitdiddle screw up this time? So he's trying to test whether array list throws an index out of bounds exception in two situations. One situation when the index is too small, namely negative. And the other situation where the index is too big, namely, the size of the list or bigger. So why doesn't this test both those situations? Yeah.
Since it stops at -1, it never gets.
Right. So what he said was, since it stops at -1, what's going to happen when this test runs is it's going to add 4 things to the list, then it's going to ask for element -1, and that's going to result in an index out of bounds exception. And the test will pass. This bit here, the list.get of 4, never gets exercised. Maybe the get method doesn't work right when the index is too big. It never gets tested, though, but the code never gets that far. So how would you test it correctly? You could make 2 tests. You could just duplicate this in another test and add the same 4 items. One of them could end with list.get -1. The second one could end with list.get of 4. That's the simplest way to do it. There's multiple ways to do it. But yeah.
You just do an if statement and have the 2 separate ones. Like if they equal this, then.
Well, an if statement by itself isn't enough. To do it all in one test, you'd have to have multiple try catches. And I could explain how to do that, but I'm not going to take the time because it's just easier to write. You can just copy and paste and create 2 separate test cases. Any other questions? All Okay, so anyway, I don't feel like writing it, but you heard what I said. And plus, I'm giving you the solutions later. So. Okay, short answers. What fundamental feature is provided by array list of integers, but not by int arrays? Yeah.
Keep adding to an array list.
Okay, so an array list, I don't know, how would I put it? It grows. I hate to do this because then, see, I don't want to set bad example. But I think if he wrote grows as elements are added, that would be good. Okay, what fundamental feature is provided by array lists of strings, but not by hash sets of strings? What can you do? Yeah.
You can get items from an array list, whereas hash sets just tell if they're in there.
Okay, you got to be careful about getting. There's a better word than that.
Return values from an array list. Is that
Yeah, we would, okay, the get, access, the word I would use is index. You can index into you can get the thing stored in an index in an array list. So, but if you said you can get or you can, I forget what the other word as long as you got the idea, we give you credit. Yeah.
Isn't there another difference of not having duplicates? Like, you can have duplicates and array lists, but not
Yeah, and we probably have to give credit for that too if the answer you gave was duplicates are allowed. But the one that the one I had in mind when I wrote the question was indexing. That's a typical thing. There's no notion of indexing in a set. Okay, now, suppose that you need a tree set of doubles, but for whatever reason you can't use tree sets today. How could you use a tree map to accomplish the same thing? So what you want to do is create a set, say, that contains 1.4, 1.6, 2.1. But you can't do that. You have to use a tree map for that purpose. What's a trick? Yeah.
You could use a loop and just make the keys what the index would be, so like 0, 1, 2.
Well, I don't think it's exactly right, if I understood what you said right. So what tree map would we create here? Yeah.
couldn't you do like, could you do like the whole thing where you do if statements and if it's like the same?
Well, what I want is, if I wrote this question again, I would ask you to sketch a tree map that would represent the same information. And now I'm thinking about what you said. So what you said was to do something like this. We have a key 1 that maps to 1.4.
Or is it 0 to 1.4?
Or 0, we make 0 the first index. A key 1 that maps to 1.6. A key 2 that maps to 2.1. Suppose that was your map. How well does that work? That doesn't quite work for representing sets. What would you do to decide if, suppose you wanted to know if 1.6 was in that, you want to know if 1.6 is in that set, but you're not allowed to use sets. How would you find out if 1.6 is in this map here? Yeah?
Set them to the same key value.
Say it again.
So create a key value, let's say 0, and then set 1.4, 1.6, and 2.1 as the values.
Right, that's how you create it, but then how would you check if 1.6 was in this map right here? What would the code look like? Yeah.
Could you make the double the key, and then you could find it out by trying to get the values?
Okay, so you're proposing a different solution. So the idea would be to make the double be the key, and let this map to something, say true. It doesn't really matter what it maps to. This is the solution I had in mind, 2.1 to true. I remember not liking this when we graded it, because there were too many answers. So back to this one right here. What would your code look like if it had to check to see whether it contained 1.6 as a value, which is the question you're going to be asking? you could iterate through the keys and see if any of them map to 1.6, which is kind of a pain. But over here, with this one, what would it take to find out if an element was in the set? Yeah?
There's like a method that contains key or something like that.
Right, so it provides, the map classes provide methods that will tell you whether something is a key in that set, in that map. So it makes it really easy. You don't even care what the values are. You just want to know, is 1.6 a key in this thing? So this is a better answer. This one works here. And I still don't like the question, though, because it's kind of complicated to explain. It involves sort of reading my mind a bit. So, my questions aren't always perfect. But sometimes I run out of time. That's where bad questions come from, is running out of time. Any questions about that one? Yeah.
Could you use like has entry and has key?
Yeah, I think it contains key is the method you'd use with the map. Okay. So here we're implementing a whole method. That's where the box is. Returns true if A, B, and C are in strictly ascending order. So be sure you look at the examples. So 1, 2, 3 returns true. Because 1, 2, and 3 are in strictly ascending order. But 5, 8, 8 does not return true, it returns false, because 8 to 8 is not strictly increasing. If I've learned anything about making tests, is I got to do more than give the specification. I got to give examples, because that really heads off a lot of questions. So we want to return true or false. Now, if I was being mean, I would make the box much smaller to prevent you from writing an if. So let's answer it without using an if. What is it we need to return? Right. If A is less than B, so we return this one. So that will be true when A is less than B and B is less than C, which means it's ascending order, and it will be false otherwise. So we just directly return it. But I know that people like to, instead of that, they want to write if this, return true, else return false. So I just say again, why bother? If you find yourself writing an if that says, if this thing is true, return true, else return false, just return the thing. Get rid of the rest. So I much prefer to see the way I had it written there originally. Okay? Any question about that? All right, now what follows is a series of questions involving loops. So here I'm looking for tokens that begin with a capital letter. I'm counting how many tokens have a capital letter, or begin with a capital letter. So the empty scanner returns 0 because it has no tokens. The second case, this and test are capitalized, so it returns 2, and so on. So as I've written a lot of tests in my life. I used to write, give completely blank pages and say, okay, write code. And that's a pain to grade. And as time has gone on, I've gone more for more and more boxes. And so this is my state of the art, where I give you the bones of the loop here, and you have to fill in the boxes. So what kind of loop are we talking about? The answer isn't while. Is this an accumulation, a searching, or a optimization loop? It's accumulation. We're counting stuff. Okay. So that means that this is just good stuff to know, that you need an accumulation variable. Now, what type should the accumulation variable be? Should be an int. It says right there. Returns an int. And so we need to declare an accumulation variable, and you can call it whatever you want. I'll call it count. And we'll start out the count at 0. And down here, if it's an accumulation loop, we're just going to return the accumulation variable at the end, so that's return count. Now I have a loop that's iterating through all the tokens in a scanner. So that's written for you. Just what else goes in there? Notice the boxes are indented the way they should be, so you know that this box is inside the while loop. So what do you have to do for each scanner, for each token? Yeah?
You could do an if statement that checks if the token uses that method is capitalized.
Okay, so if it's capitalized, we'll worry about that in a second. What do? We just add one to count. And how do we know if the token starts with a capital letter? Yeah, normally, did I not give a hint here? Yeah, character dot is uppercase, right. I didn't leave enough space here. So I told you there is this method is uppercase. And what are we testing?
Token.char at 0.
All right, so yeah, okay, I've made a mess here, so I'm gonna have to do plan your space out better than I did. So we ask, is the first character in uppercase? If it is, we increment our count. If it's not, we don't increment the count. And we're all done, we return. So questions like this, figure out what type of loop is being asked for, accumulation, optimization, or searching. And that can really narrow down what you need to do. I mean, if you know it's accumulation, you know you got to declare a variable, you know what type it is, you know to return it at the bottom. So you just reduced it to the question of what do you put in the box. Yeah. What's that? Which method are you looking at?
You think there should be an S there.
Oh, you're right. Yep. And that's something we definitely overlook that. Yeah. Token.char at 0. Yeah.
Are we going to get dominated by variable names?
No, we're not going to. It's a reasonable question because we do that on assignments, but yeah, we won't say bad variable name. All right. Let's see the next one here. So this is related to that question we saw before. I want to know, we have an array of ints. Do they appear in strictly ascending order? So we see these examples again. So the empty array returns true. I haven't really talked about this syntax. You can guess what it does. Like this last one right here, it creates an array that contains 3, 4, 5, 6, 4. Oh, yeah, and it says so right here too. So I just want to know, is this array here ordered? So this, it's a little bit obscure what kind of loop you're writing here. In fact, you can think about it a couple ways. You want to take a stab at it? It's not an optimization loop. Is this an accumulation loop or a searching loop? Yeah?
You could do a searching loop and search for a pair that is not in something.
Okay, that's how I would think about it. You're searching for a number that's out of order. Okay? So let's think about it. So for a searching loop, do you typically do anything before the loop starts? No. What would the loop contain in a typical searching loop? What kind of statement is contained in the body of the loop? An if statement. So if we found what we're looking for, return something. So in this case, if we find a number that's out of order, what do we return? False. Because we return false to signify all the numbers aren't in order. And then if the loop ends without having found anything out of order, right, we return true. So we got that nailed. We don't need anything up here. So we've got this starting at index 1 instead of 0, and I made sure that you saw that. So when we look at a given index, how do we tell if it's out of order? So if something is true, we're going to return false. So if the element at the given index here is out of order, return false. How can we tell that? Let me go here.
If index is greater than index plus 1.
Okay, we don't want to compare index, we want to compare array, but you got the right idea. So if array sub index, we're going to compare array sub index to array sub what? Index minus 1. That's why I started at 1 instead of 0, because first one is always in order. The question is the next one. So what comparator, how do we compare? Let's see, yeah, if it's less than or equal. So if the element at index 1 is less than or equal to the one at index 0, then it's out of order. It has to be greater than. So there it is. Not a lot of code to write. You still have to think about what you're doing and piece together the code. But what you should do is should look fairly simple. Because my fundamental rule of making up tests is to make them easy to grade. So if your answer seems overly complicated and it would be a pain to grade, it's probably not right. Any questions I could answer about this one? Yeah.
So it's only boxes to no bubbles or whatever?
Oh, there will be, he's asking, is it all boxes? No, sometimes you'll have things to shade in, bubbles to shade in. You'll see examples of that maybe in the 2018 exam. I'm not sure. Okay, not quite done yet, so don't leave, please. Well, I think we have time for one more, and then you'll just have to look at the solutions for the rest. So what kind of loop are we talking about here? Okay, we want to find the largest number in a set, and we're assuming it's non-empty, and it's required to contain only positive numbers. So what do we do? That's an optimization loop, obviously. So in an optimization loop, is there typically stuff written before the loop? All right, we need an optimization variable. And we're talking about doubles here. So we're going to call it large. I would call it largest, and it would work fine, but I don't. Same name as a method. That bugs me sometimes. So the question is, what should we initialize it to? So let's leave that for now. Now we iterate through the set. Well, actually, when we're through, what are we going to return down here? All right, we're just going to return large. Now, in an optimization loop, as you look at each element in the set, what do you do with it? Okay, so if it's bigger than large, you have a new value for large. So if large is greater than, if D is greater than large gets D. Now, the question is, what should we initialize large with? Now, you want it to be, initialize it with something that's smaller than anything that can occur in the set. Okay? What do we know about the stuff in the set? Required to be positive and non-empty. So what could we initialize large to? 0. What else would work? Any negative number would work. Okay? Questions? Yeah.
Since it's non-empty, could we just not initiate it?
Well, he's asking, since it's non-empty, could we just skip initializing large? Well, the problem is, if you don't initialize large, the first time you try to compare D to large, that's a problem. Now, suppose this weren't a set. Suppose it were an array. What would be a cleaner way to do it instead of initializing large to 0? You'd initialize it to the first element. And maybe there is a first element method on sets, but I chose not to use it. So in this case, we just initialize it to large. There was a question there.
No, you got it.
Okay. Yes? Oh, yeah. This typo here has been dogging me for 3 years now. I keep forgetting to correct it. Yeah, that's a typo. Okay. Any last questions? All right, so I'm going to close. Okay, give me one question, then I'll give you my closing thought. Yeah. Scroll which way?
Down.
I'm not sure what down is, but you mean like this?
Yeah.
All right. So I remember being in graduate school and I had an oral exam. Yeah, you definitely want to hear this. And I was nervous about it, so I asked a more senior graduate student for advice. And his advice was to enjoy the exam. And that sounds like crazy advice, but actually in that exam, midway through, I realized, well, I'm enjoying myself. So it may be hard to imagine enjoying the exam, but it's sort of your chance to show off what you know. And if you succeed in enjoying it, you'll do better. What's the harm? So I hope you enjoy the exam.